Hey folks, welcome back. And now we're going to be looking, this is part two video, so we're going to be looking at IV solutions and flow rates. So when we talk about intravenous administration of a drug, the solution is put directly into the vein, and we would use this process to deliver a drug over a period of time, right? And like a PO would be per oral, would be all at once, right? And here you can control the rate at which the patient receives it. And remember, rate always means how something changes over time. So it's a ratio with time in the denominator. And once again, you can think of these as conversion factors. So here's a few equations. IV drugs are administered at a specific volume per unit of time. This is called flow rate, right? Solution volume divided by time. An example unit would be like milliliters per minute, okay? Something like that. Some volume of the IV solution divided by the time. Um, so then on the right-hand side here, there's another rate that we can talk about, which is the rate of that the drug is actually administered. So the IV drugs are administered at a specific amount of medicine per time. This is called the administration rate. So this would be the mass of the drug, or solute mass per time. Something, for example, like milligrams per minute. Okay, so we have volume per time and mass per time. And there's a connection or a link between these two rates, and that connection is concentration. So concentration, administration rate, and flow rate are all connected, and if you know any two of them, you can solve for the third. Right? You can find the third using dimensional analysis. Dimensional analysis, remember, guides us through these calculations by focusing on the units. So let's say you had the concentration and the flow rate, and you want to know how much medicine is your patient getting every minute. Right? So we can set up and manipulate these equations if we take the concentration times the flow rate. Notice the concentration is mass over volume, flow rate is volume over time, and multiplying these would result in mass over time. So you get the rate of the medicine administered. Okay, if we wanted to find the flow rate, right, we want volume on top, we can invert the concentration, multiply by the rate medicine administered, and that would give us solution volume over time, right? Volume over mass times mass over time gives volume over time. You can see how these combinations will work out, right? Using dimensional analysis to guide us through. Basically, the variable you want on top, go ahead and put it there. The one you want on the bottom, put the second term with that on the bottom, and then the one that you don't need should cancel out. Okay. So the third example, like if you wanted to find concentration, which is knowing the other two, how would we find concentration, right? So let's say you want solute mass over solution volume, right? What would we do with the other two terms to get that? Well, we want a mass on top, right? And so if we take solute mass over time, which is the rate of medicine administered, and then we want volume on the bottom. So if we take the flow rate inverted, right, we get time over volume of solution. So time cancels out and we're left with mass over volume. Right? It's just kind of like a puzzle, right? Think of it like a fun puzzle. You have to figure out how to get mass on top and volume on the bottom, and that's it. Okay, and so we can show that now here, right? The rate of medicine administered times the inverted flow rate equals concentration. And so now, if you keep track of these three, right, and you have them in your notes, then you can always find the third from the other two, whatever they might be. All right, let's solve a couple problems together. All right, so here's our first example problem. A diabetic patient suffering from hyperglycemia is receiving an insulin solution by IV at a flow rate of 25 milliliters per hour. The concentration of the insulin solution is 0.4 units per milliliter. How many units of insulin per hour is the patient receiving? Okay, let's gather our thoughts here. Let's think about what do we have? What do we know? Well, we have two numbers. They're both ratios. 25 milliliters per hour and 0.4 units per milliliter. So 25 milliliters per hour. What kind of number is that? Flow rate, concentration, administration rate. Okay, what is that? Volume over time. That's going to be the flow rate, right? And then we also have 0.4 units per milliliter. That's the concentration. And we are looking to find the units per hour, which would be the administration rate. Okay. Now, you can go back and look at the equations that we just wrote and figure out like which one to use, right? But the strategy here is that our final answer will have units on top and hours on the bottom. Okay, so we're going to find the piece of information we have that has units on top, which should be right here. And then we want hours on the bottom, which would be the flow rate. So times 25 milliliters per hour. And if it works out, then milliliters should cancel out, and it does. So this is working well. Okay. And then we will multiply 0.4 times 25, and your patient is receiving 10 units of insulin per hour. Okay, so concentration times flow rate gives administration rate. And here was the slide with the work that we just went through. So you can pause it here and take a look at this if you want. And we'll move on after that to the next question. All right, next question. IV solutions of heparin, an anticoagulant, are available as 25,000 units per 500 milliliters in a D5W solution. D5W, right? Do you remember what that is? So it's 5% dextrose in water. Anyway, an order is given to infuse 750 units of heparin per hour. At what flow rate in milliliters per hour should the IV solution be infused into the patient? And then there's a second question we'll get to next. All right, so let's again gather our thoughts and look at what we have. So we have 25,000 units per 500 milliliters. And we have an order of 750 units per hour. And we are looking to find milliliters per hour. Right, so what do we have? We have 25,000 units per 500 milliliters. That would be the concentration, right? We also have the administration rate, 750 units per hour. And then we're looking to find the flow rate, right? Milliliters per hour. And again, we can look back at the equations that we have, or we can just simply work our way through this with dimensional analysis and see that we want milliliters on top. And so milliliters only shows up in one place, which is the concentration. And so we will flip that to put milliliters on top. So we have 25 milliliters, 500 milliliters over 25,000 units. And then we want hour on the bottom, and that only shows up in admin rate. And quite nicely, that also means that units will cancel out. And we will end up with milliliters per hour. And you will give your patient 15 milliliters per hour. Okay, now the next question is like a bonus question, right? How long will it take for 1 milliliter to drip? So this question relies on the answer we just got. When you say how long for 1 milliliter, what that really means is time per milliliter, right? Or time over volume. And the answer we just got is volume over time. And so if we take that and we flip it, we can say that 1 hour would be 15 milliliters. 15 milliliters per hour, hour per 15 milliliters. Same thing, right? So that's probably not the best or most appropriate units. Let's see if maybe minutes would be better, right? And so we can, instead of hours per milliliter, how many minutes per milliliter? And so there we can say 60 minutes per hour. Hours will cancel away, and we can get that it would take 4 minutes per milliliter to drip, right? So that's another way of thinking of it. 15 milliliters per hour, or 1 milliliter every 4 minutes, right? Or 4 minutes per milliliter. All right, let's end here. By the way, there's some heparin bags, and you can see here the 25,000 units per 500 milliliters in a D5W bag. Also available would be 1,000 units per 500 milliliters. It doesn't technically have the concentration here, but the bag itself is 500, so we know that that's what it is. And this one is in 0.9% sodium chloride. What would that be? That's what we call normal saline, right? So a couple differences here. And they're both heparin, but it's important to know which one you want. And also very important to realize that their concentrations are very different, right? A difference of 25 times concentration. So if you're going to give your patient this one, you better know which one you have and do the right calculation to figure out how much to give them. Okay, in part 3, we'll come back and work through lots more problems.